Alright, today's lesson is 8.4, solve addition and subtraction equations. So first off, we're looking at the subtraction property of equality. So that's saying if you subtract the same number from both sides of an equation, the two sides will remain equal. So for our example, we have 3 plus 4 equals 7. So if I subtract 4 from one side, I have to do it to the other side to make the equation stay balanced. So right here we see that when I subtract 4 from this side, I end up with 3 plus 0, which is just 3. And if I subtract 4 from this side, I get 3. So I end up with 3 equals 3. So even though 3 plus 4 equals 7 is not the same values as 3 equals 3, they're still balanced. They're still equal. Okay? So if you subtract from one side, whatever you subtract from that side, you have to do the same to the other side. You understand? Any question with that? You'll see more of what we're talking about in a minute. So, inverse operations are operations that undo each other. So, you can use subtraction to undo addition, or addition to undo subtraction. You can also, tomorrow when we get into doing the multiplication and division, you can do the same thing with those. So, you could use division to undo multiplication, or multiplication to undo to division. But today, we're focusing on the addition and subtraction. So let's look at example 1. Go ahead and write this down. Example 1, D plus 5 equals 23. Now, the EX, the inverse operations? Yeah, write down the inverse operations. You need to know that.
Is this like what we did yesterday?
Well,
except it's addition.
Except this time we're going to solve to find what the variable is.
Okay.
So this time we're actually, the other day we were just writing the equations. Today we're going to solve the equations.
That seems pretty easy.
It's not bad. As long as you don't tune me out and listen to what I'm telling you, you should be fine. Alright, you ready? So, for example 1, we have D plus 5 equals 23. The idea is to get the variable by itself. Okay, so we need for D to be by itself. But as of right now, and when I say by itself, I mean by itself on this side of the equal sign, right? But right now we've got that plus 5 there also. So I need to get rid of that 5. And since this is plus 5, what's the inverse operation of addition? Subtraction. So if I subtract 5, what happens to this 5? It's 0. It's no longer there. So really, it cancels this out, right? And all I'm left with is D on that side of the equation. But I can't just say that D is 23, right? So I've got to do the same thing to this side. Since I subtracted 5 over here, I have to subtract 5 here also. What's 23 minus 5?
18.
So I get that D is 18. So just to check it, I'm going to rewrite this equation, but I'm going to put in 18 where D is. So 18 plus 5 equals 23. Is 18 plus 5 23?
Yep.
So it means that D was 18. So D equals 18 would be my solution. Okay, so when it shows that you're adding and you need to get rid of that plus 5, that positive 5, you use subtraction to undo it. But you have to do it to both sides. Does anybody have a question? Okay. Alright, so you may have room to add this to yours. I didn't have enough room, so I had to go to another sheet of paper. So, just like we have the subtraction property of equality, we have the addition property of equality. So if you add the same number to both sides of an equation, the two sides will remain equal. So I have 7 minus 4 equals 3. I'm going to go ahead and pause this so y'all can write that down. Alright, so if you add the same number to both sides of the equation, the two sides will remain equal. So here, we have 7 minus 4 equals 3. So I can add 4 to both sides, which if I have a negative 4 or minus 4 and I add 4, that ends up giving me 0. And 7 plus 0 is 7. If I add 4 over here, 3 plus 4 is 7, so I end up with the 7 here. So because I did the exact same thing to both sides, the equation still stays balanced. Does that make sense? Okay, so let's look at example 2. Does everybody have this part up here written down, the words? All right, I'm going to go ahead and move that up a little higher. So if you'll notice in example 2, we have A minus 5/8 equals 7/8. Now the nice thing about this one is we already have a common denominator, so that's going to make it a little bit easier. That won't always be the case, and you'll see that when we start working in a little while. Alright, so the object of the game, or the object of the equation here, is to get A by itself so we can figure out what A is, right? So the only thing that's in our way is this minus 5/8. So how do I undo that? By adding, what? 5/8. I can undo it by adding, so what happens here is this basically just cancels out and leaves me with A. But I've got to do the same thing here, so I've got to add the 5/8 here also. So fortunately I have that common denominator already. 7 plus 5 is 12, so I get 12/8. And if I write that as a mixed number, that's 1 4/8. And if I simplify that, what would that be? 1 1/2. And just for the sake of checking it, if I use that 12/8 where A is, right here, and I subtracted 5/8, what do I end up with? 12 minus 5 is 7/8. So it works. Any questions there? Okay, when you finish writing down that example in your notebook, go ahead and turn to page 306. Oh, I'm sorry, it's 307, not 306. 307. Does everybody have that written down? Alright, so here are the first problems on page 307. So number 1, yours has the blanks in it, so it looks a little bit different. But what am I going to do in order to get n by itself? What do I have to do? Okay, but listen, if I add 35, is that going to get rid of the 35? No, so that means what I need to do? Subtract the 35, because remember the object is to get n by itself. So if I subtract 35 from each side, and yours is going, instead of going vertically, yours goes horizontal. So you can see where you need to fill in that negative or minus 35. So on this side though, the plus 35 minus 35 cancels out and leaves me with just n. And then over here, 80 minus 35 would be what? 45. So we get n equals 45. So we could go back and check that. Logan, are you with me? Okay, so if you put 45 in for n plus 35, what does that give us? 80. So it works. Okay, then number 2. Alright, so we have 16 plus x equals 42, and the object is to get x by itself. So what am I going to have to do with this 16 here? I'm going to have to subtract it. So subtract 16, and if I do it to this side, I have to do it to this side also to keep it balanced. So those cancel out and leave me with x. And 42 minus 16. Just go ahead and do the math up there. And we get 26 for x. So to check it, 16 plus 26 would give me 42. So it works. make sure that you are writing this down. You should have room in your book to write that down on number 2. Anybody still writing any of that down? Alright, let's look at number 3 then. Alright, so number 3, the object is to get the variable by itself, so we need y to be by itself. So what am I going to have to do with this positive 6.2? I've got to subtract. I've got to use that inverse operation. So just make sure that you're using the inverse operation here. You don't want it to be the exact same operation, or that's not going to help you. It's going to be the inverse operation. So those cancel out and leave me with y. And 9.1 minus 6.2. 2.9. So then to check it, 2.9 plus 6.2 gives me 9.1. And I don't care if you want to check it with your calculator anyway. While I'm thinking of it though, when we do take the ACAP, there will be a portion of it where you are not allowed to use calculators, and there's a portion you are allowed. So closer to time, we'll probably be going back over doing the adding, subtracting, multiplying, and dividing fractions and decimals without calculators, just to make sure you remember how to do that. Alright, moving on to number 4. So the nice thing about number 4 is we already have a common denominator. So I need to get m by itself, so what am I going to do to each side? Subtract 3/10 from each side. So that means these cancel out and leave me with m. And over here, 7/10 minus 3/10 is going to give me 4/10. And then I can simplify that down to 2/5. And if I went back and checked it, put in 2/5 for m. Oh, no, well, I probably should have gone ahead and used my 4/10 there. Let's do that instead. Let's put in 4/10 since they've already got that common denominator, plus 3/10 equals 7/10. So it works. Any questions so far? Okay, so on those 4 examples, we were using the subtraction property of equality. We had to subtract from both sides. On the next 3, we're going to be adding, because if we'll notice here, we have z minus 1/3. So to get z by itself, what's the inverse operation of subtraction?
Well, addition.
Addition. So I'm going to have to add 1/3. So we'll add 1/3 here as well. These cancel out. We'll leave me with z. I'm waiting just a minute before I go on. You with me? Any questions so far? Okay, so right here when I add, 2/3 plus 1/3 is 3/3, and then I have that whole number 1, which would be what?
2.
This would be 2. And I could go back and check it and I'd get the same thing. So I could start with that 1 and 3/3, subtract 1/3, and that still gives me 1 and 2/3. So that's just a way of checking it. Any questions? Okay, look at number 6. So we're trying to get x by itself. I always like to circle it or highlight it or do something. It helps me kind of focus in on what I'm doing. So here I have x minus 24. So to undo this, what do I need to do? Add 24. Because the inverse operation of subtraction is addition. So if I add 24, that's going to get rid of this negative 24 so that x is all by itself. So these cancel out, leave me with x. But because I added 24 here, I have to add 24 here as well. So when I add those, what do I get?
36.
So I get that x is 36. And if I put 36 in for x and subtracted 24, I would get 12. Any questions? Okay, let's look at number 7. Alright, so I'm trying to get W by itself.